studying superclusters, a few cosmologists are beginning to question some of our most cherished scientific principles. According to our current model of cosmology, the laws of physics suggest that structures much bigger than Laniakea cannot exist.
If I look at this sheet of sandpaper, at this scale, it looks completely uniform. There's no pattern to it. But if I zoom in using this portable microscope connected to my laptop, suddenly I see structure, mottled colours of black and brown and yellow, shades and speckles, which are completely invisible when I'm zooming out looking at the whole sheet.
According to our current theory, a similar principle applies to the universe. After the Big Bang, matter was scattered pretty evenly throughout the cosmos, because the same forces acted equally on everything. The power of gravity brought together galaxies and then galactic clusters, but over a certain size, gravity is too weak to bring structures together. Like my sandpaper, the universe should appear featureless.
This is what's called the cosmological principle, and it's one of the foundational pillars of modern cosmology.
But recent findings have cast some doubt on this extremely important idea. Remarkably, one of those discoveries was made by a student. Alexia teaches violin to students to help fund her way through her PhD, and while doing her research, she came across something remarkable.
It was really exciting, but completely accidental. My supervisor had this idea of using this new technique to map what's out there in the universe, and I happened to stumble across this giant, great structure. It was completely serendipitous.
The ingenious method which Alexia used involved very distant objects called quasars. These are immensely bright centers of galaxies, billions of light years away, thought to be powered by supermassive black holes. For Alexia, they were extremely useful because you could use them as if they were spotlights, shining a light on the dark corners of the universe.
We're going to use these two torches to represent quasars, these very distant, powerful sources of light. Now, you have a simple demo here, this plate of glass. Tell me what these blobs are.
These little blobs here are representing faint galaxy and galaxy clusters. Now, without the quasars, we wouldn't be able to see them. They're too faint and too distant. But with the quasars, they essentially act like a torchlight that illuminates this faint matter.
As the light passes through a galaxy, some of it is in effect blocked.
We can see that some of the light was absorbed, and therefore something must have absorbed that, and therefore there is matter lying there.
Using this method, Alexia has been able to create a 3D map of a huge chunk of the universe, and she seems to have found a pattern. These red blobs are all galaxies or galactic clusters, and together they appear to form a giant structure in the shape of an arc.
We've used 3 different statistical tests, and all 3 of the tests show that the giant arc is actually more than just a random fluke.
It's really there. Why is it so unexpected and exciting?
So we have this thing in cosmology known as the cosmological principle, and it says to us that on the largest scales there should be no structure or pattern in the universe. The cosmological principle has a specific cut-off limit, and that's estimated to be about 1.2 billion light years. But the giant arc here is over 3 billion light years wide, so it begs the question how something like that can form in our current understanding of cosmology.
The giant arc is so big that if we could see it from Earth, it would look 35 times bigger than our moon, even though it's 9 billion light years away. The reason it's so mysterious is because it's too big to be held together by gravity. And it's not the only one. Even bigger superstructures have been found, such as the Hercules Corona Borealis Great Wall, thought to be 3 times bigger than the giant arc. It's early days in the story, but this debate could be a game changer, because all our theories of how the universe was formed after the Big Bang are based on the cosmological principle.
Time will tell, I guess. It's still too early to be sure.
It's still too early, but everything is built on top of this assumption of the cosmological principle. So it's kind of like taking the bottom piece of a Jenga puzzle out and the whole thing collapses.
Carrying out investigations at these mind-boggling scales continues to challenge our most cherished beliefs, transforming everything we thought we knew about how the universe behaves and how we came to be here. And I can't wait to see what we discover next.
There you go, folks. Take care.